Hello everyone, today we will see the design of wall footing. Myself Dr. Sakai Ruban, Professor and Head, Department of Civil Engineering, Rohini College of Engineering and Technology. Let us see the design problem. Design of footing 250 mm thick as a masonry wall with a support to carry a design load of 200 kN per meter at a service state. Consider unit weight of the soil is 20 kN per meter cube. Angle of repose is 30 degree. Q0 is equal to 150 kN per meter square. Then gamma is equal to 20 kN per meter cube. Then without the member, footing is 250 mm. Load is given by 200 kN per meter. Angular repose is 30 degree. Characteristic compressive strength 20 Newton per mm square. And characteristic tensile strength is 450 Newton per mm square. First of all, we have to find out the width of the footing and the depth of the foundation. The depth we have to find out by using this relation, that is H is equal to Q0 by gamma into 1 minus sin pi divided by 1 plus sin pi square. So 150 divided by 20 into 1 minus sin 30 divided by 1 plus sin 30 square, that will be equal to 0.83. So approximately you have to take a depth of the foundation as 1 meter. Then without the footing you have to take it as B is equal to load per say bearing capacity of the soil. So load is 200 divided by 150, that will be equal to 1.35. Next we have to find out the loading. First we have to determine the self height of the footing. So self height of the footing is equal to L into B into D into gamma. So L 1 meter, B is 1.35, depth also 1 we have to provide. So into 25 is the unit weight. So we will get a 34 kilonewton per meter square. Then total load is equal to PU, that is actual load plus self height, that will be equal to 234 kilonewton per meter square. The actual without the footing is equal to 234 divided by 150, that will be equal to 1.56. So we have to take the value of with this 1.6 meter. Next we determine the net upward pressure, that is P0 is equal to load by width into 1 meter given. Okay, so 200 divided by 1.6, that will be equal to 125 kN per meter square per meter length. Then depth basis of bending in compression, M is equal to P0 by 8 into B minus B into B minus B by 4. Substitute the values, finally we will get a value of M is equal to 32.43 kN per meter. The factor moment 1.5 into 32.43, that will be equal to 48.645 kilonewton meter. So ME limit is equal to 0.36 xv max by d into FCK 1 minus 0.42 xv max by d into BD square. So substitute all the value get it from in terms of BD square. So equate ME is equal to MU limit. So substitute all the value here. B we have to take it as 1 meter. So from that we determine the value of D, that is 132.78 mm. So cover we have to provide as 60 mm. So the depth of the footing is 192.78. So we have to take the depth as 200 mm. Normally the shear will be occur in the footing. There are two types of shear normally happen. One is one way shear, another is a two way shear. So depth basis on the one way shear we have to take it as assume that percentage of reinforcement used in this footing is 0.3%. From that we determine the tau V value. So that we have to find the tau C value in table number 19 of page number 73. So tau C is equal to 0.38, tau V is equal to 0.38 into K, that is a factor. So that is page number 73 we will get a value of K is equal to 1.20. So tau V is equal to 0.38 into 1.20. So tau V is equal to 0.456. So by using this we have to find out the value of D. So the critical section lies D distance from the face of the wall. So V is equal to 1.5 P0 into A. So A is equal to B by 2 minus B by 2. Substitute the value here and we will get a value of A is equal to 675 mm, that will be equal to 0.675 meter. So V is equal to 1.5 factor load 1 by 125 into 0.675. We will get a value of shear force is equal to 126.56 Newton per mm square. So tau V is equal to shear stress is equal to VU by BD. So from that we have to determine the D value. So equate this value 0.456 is equal to 126.56 into 10 to the power 3 divided by 1000 into D. From that we determine the value of D, that is 280 mm. So overall D is equal to 280 plus 60, that will be equal to 340 mm. The critical section lies D distance from the wall. So from that critical section we determine the D value is 340 mm. Next we have to determine the reinforcement. So we know M is equal to 0.87 Fi into AST into D minus 1 D into 1 minus Fi AST divided by BD FCK. Substitute and simplify this equation. Finally we will get a value of AST, that will be equal to 519.83 mm square. So provide 12 mm diameter bar at 200 mm center to center. Like we have to determine the distribution rod, that is 0.12% of B into D, that is 300 mm square. So that provide 12 mm diameter 200 mm center to center for main reinforcement. Also we have to provide 300 mm square for AST for distribution steel. Thank you.